Okay, so here got a price as a function of demand, and I want to find demand as a function of price, right? So this is similar to what's on the third exam, okay? So this was on your quiz. So minus 1,000. So P minus 1,000 equals negative 0.1 e to 0.002 d, right? Okay, so divide by negative 0.1, right? Goes away. So I get e to the 0.002 d, okay? Everybody okay? So far so good. All right. So now, because I have e to the power, I'm going to take the natural log of both sides, right? And that means the e goes away. And so I'm left with 0.002d on the one side, and the natural log of this fraction on the other side. Okay. Now I want to solve for d. So again, just divide 0.002, and so I get equals d, right? So this is d. Now I can plug in different values of p and come up with different demands, right? And so you can say p is zero, a zero price. I take the natural log of negative 1,000 over negative 0.1. Negative over negative is a positive, so no problem there, right? And in fact, this numerator has to be negative, so p must be less than 1,000, right? Because this has to be negative. And so again, p must be less than 1,000. So if this is $999 minus 1,000 would be negative 1 over negative 0.1. Now if I charge 1,001, I'm going to get 1 over negative 0.1, the log of a negative number, which you can't do, right? And so the maximum price in this case would be $999. I cannot round it off. I cannot charge $1,000 because that would be the log of 0, which you cannot do either, right? Yeah?
I'm just confused just because you have two variables. You have p and d in the equation, right? So that's always going to be like a...
Yeah, so then I would plug in different values for p. So different prices, I plug in 300. If I charge $300, what's demand? If I charge 200, what's demand? If I charge 100, what's demand?
Well, on exam 3, you have a question asking us to solve for q without giving us a price.
So just solve for q though.
But what do you need a price to solve for q because you have p?
Well, what's the part B, C, D on there?
It's just 4. It says you'll need to solve in terms of p, solve for q.
Yeah, so I think on that one you should use that for the rest of the question.
Oh, so it's like...
So it's like this, basically. We solved for D, but we still have two variables. So you're still going to have P and Q. So you're not like getting a number out of it, but you're making an equation that we could have just...
Yeah, you're getting an equation.
Oh, so it's an equation you're looking for? Not
Yeah, now, so here, if I know D, I can find P. But usually P is the variable that, or P is the known. So usually I know P because I can make up price, and then I want to find out what's the demand for the good given different prices. And so rather than plug in values of different P's and solve for D a bunch of times, you do it one time, you find an equation in terms of price, right? So you find demand as a function of price, and that way I can plug in different prices and come up with different levels of demand, right? Okay? Okay. So that would be helpful, I think. Right? right, let me just do number, I know I did this yesterday, but I want to do it on the video here. Somebody asked about number 6, depreciation. So you have your principal, and I know we talked about your minivan, right? I'm just going to do it on video really quick here. And I have the principal, and here you can do it with E, or you can do it, in this case, I did it with a annual depreciation model, right? Like a Kelley Blue Book comes out every year, right? So, what's the annual depreciation rate? Well, again, this is 1 plus R, okay? So that equals 0.8, so R equals a negative 0.2, right? So we talked about that. That means a depreciation. Now, if R is greater than 0, it's an appreciation, it's appreciating in value, but we know cars in general depreciate in value. There are exceptions, they're called classics, right? And then 3 years, so for 3 years you plug in 84,000 times 4/5 to the third power was, what did we say that was? 50,000, something like that? $43,000, no. What did we get for that? $43,000, yeah. So almost half. So it loses 20% every year. If that were 20% of the original price, it would lose 60% over time. That's not how cars depreciate. Again, we talked all about that yesterday, right? So that would be again, this is your 1 plus R. 1 plus R is 0.8. R must be negative 0.2. Check, check, right? Then just plug in the number of years that it's doing that for. So this is a compound growth formula, but it's a negative growth rate. Yeah, Jana?
So there is a question about earthquakes on the exam.
Oh yeah, so we did the Richter scale.
Yeah, could you go over that again?
Yeah. Okay. So Richter scale is a log, right? And we find, where was that chapter? It's, what is it? I think it's R equals, is it log? I over I naught, but I naught is just 1. So say 1. Is that right? 10 to the R is the intensity?
You don't have it below.
Oh, it should be ln. No, it's log base 10.
Log
No.
base 10.
Yeah. Yeah, R, so Richter scale. This is the log of I over I naught, but I naught is just a minimal intensity of 1, right? So we had the North Sumatra earthquake of 9.0, Christmas earthquake in 2004. You guys remember that? 250,000 people died in the tsunami. So that was R sub Sumatra is 9.0. And the same year we had an Alaskan earthquake of 6.8. So I say, okay, what's the relative intensity, right? So you want I of Sumatra and I of Alaska, and then you're going to find the I of each. You're going to take this and you're going to divide, right? So once you find, so this is the Richter number, the Richter scale is the log of the intensity. So 10 to the R is I. Okay. Okay. So then you want to find the intensity of Sumatra, 10 to the 9th power, divide that by the intensity of Alaska, which is 10 to the 6.8, right? And you want to find the ratio there. Okay.
So you're taking 10 to the 9 divided by 10 to the 6.8,
Yeah,
and that's the answer?
yeah. Okay.
On the exam,